We've seen that these 6 trig functions apply to right triangles, right? The sine of an angle is the opposite of the over the hypotenuse. That only works in a right triangle. So what do we do when we have triangles that are not right triangles? Here I have a triangle that is an acute triangle. All 3 angles are supposed to be less than 90 degrees. And here I have an obtuse triangle where one of the angles, in this case angle B, is larger than 90 degrees. The other 2 are acute. And so what happens for these triangles? So what we want to do is draw a line from the point C down, perpendicular to the opposite side, and I'll do the same thing over here. If I draw a line down so that it's perpendicular to this line, okay, and so they form right angles. In the acute triangle, if we look at A, angle A, the sine of A is going to be the opposite side over the hypotenuse. And so for this triangle that I created with this altitude, which is perpendicular to this side, we'll call that H. For this triangle, this is a right triangle. The opposite of A is side H, and the hypotenuse will be B. That's opposite the right angle. And so the sine of angle A will be H over B. And if we look at the obtuse triangle, we have the same situation where angle A forms a right triangle with this altitude that we've drawn, and again we'll label that as H. And so this big right triangle that I've drawn here, the opposite side is H, the hypotenuse is B. And so sine A is H over B. That's true for both triangles. And if we look at angle B, the sine of angle B, again, is the opposite over the hypotenuse. In the acute triangle, the opposite is H. The hypotenuse is A. That's opposite the right angle. So the sine of B will be H over A. And the same thing in the acute triangle. If we look at angle B, which is this angle here, the opposite side is H. The hypotenuse for this triangle is A. And so sine B will be H over A. And so what we want to do is multiply both sides by B over here, and we get B sine A equals H. Over here we'll multiply both sides by A, and we get A sine theta, sine B is equal to H, and these both equal H. So if they both equal H, then they must be equal to each other. So B sine A must be equal to A sine A. A sine B, right? So B sine A is equal to A sine B because they both equal H. So now what we want to do is divide both sides by the sine of A. They cancel over here, and we get B equals A sine B over sine A. Now we want to divide both sides by sine B. They cancel over here, and we have B over sine B is equal to A over sine A. And the same, using the same method, we could also prove that this will also be equal to C over sine C. And this is known as the law of sines. Which says that the length of any side divided by the sine of the angle opposite of that side will be equal to any other side divided by the sine of the angle opposite that side as well. And so we can use this law to solve triangles that are not necessarily right triangles. We can do that using this law. This is example 1. We have a triangle where we know that angle A is 65 degrees, side A is 20.0 meters, and side B is 15.0 meters. And we're being asked to solve for the unknown information of the triangle, which will be angle B and C, and also side C. And we need to use the law of sines to do this. So our strategy is to look for information that is opposite of one another. In other words, we know angle A and we know side A. That means we definitely want to use an equation that has A over sine A in it. And then the third piece of information that we know is the length of side B. And so we're going to use A over sine A equals B over sine B. We will ignore the C over sine C part. So we're going to use A over sine A is equal to B over sine B. We will plug in the information that we know and then solve for the unknown. So we know that side A is 20 meters, angle A is 65 degrees, side B is 15 meters, and angle B is what we're looking for. And so we want to solve the equation first for sine B. So we'll multiply both sides by sine B so that it won't be in the denominator anymore. We will have sine B times 20 meters over sine 65 is equal to 15 meters. And then we want to get the B by itself, so we'll multiply both sides by sine 65 over 20 meters. That cancels the sine 65, cancels the 20 meters, and we're left with sine B. Sine B will equal 15 meters times the sine of 65 degrees divided by 20 meters. Now, I don't want to solve for the sine of B, I want to solve for just B, so I need to take the inverse sine of both sides. I might go ahead and work this out first, and then take the sine B of both sides. So I have 15 times the sine of 65, close parentheses, divided by 20 meters, and we get that the sine B will be equal to 0.6797. Now I'll take the inverse sine of both sides. And make sure you're in degree mode. Take the inverse sine of 0.6797, and we get the angle B is equal to 42.8 degrees. And so B must be 42.8 degrees. And from here, we can determine angle C, because we know that all three angles must add up to 180. So angle C plus angle B plus angle A must be equal to 180. And so C is what we're looking for. B is 42.8 degrees. A is 65 degrees. And again, these add up to 180. And so C plus 65 and 42.8 is 107.8 degrees equals 180 minus 107.8 from both sides. These cancel, and C is equal to, looks like 72.2, I'll just be sure, 180 minus 107.8, 72.2. So angle C must be 72.2 degrees. The only thing left now to solve for is C, and again we'll need to use the law of sines to solve for this. This is not a right triangle, so we can't use Pythagorean theorem, so we'll have to use the law of sines. And so I need to make sure that I use the part of the equation that has what I'm looking for in it, which is side C, and I can use either A over sine A or B over sine B. Okay, and it doesn't matter which one I use, so C over the sine of C will be equal to, I'll use A over sine of A. Okay, and we're looking for side C, so we'll multiply both sides by the sine of angle C. These cancel, and we get C is equal to A sine C over sine A. Now we plug in the numbers that we know. A is 20 meters times the sine of C, which is 72.2 degrees, so the sine of 72.2 degrees, divided by the sine of A, which is 65 degrees. Okay, and again, we'll type this into our calculator, and we will get an answer for side C of 20 times the sine of 72.2, close parentheses, divided by the sine of 65, close parentheses, equals 21.0 meters. So side C must be 21.0 meters. Now we've solved for all of the information of the triangle. We know the length of all three sides, and we know the measure of all three angles. This is example 2. Again, we have an acute triangle, and we know that the length of side C is 59 feet, angle B is 108 degrees, and angle C is 25 degrees. And so again, this is not a right triangle. We can't use just the trig functions alone. We need to use the law of sines. And so again, we want to look for a side and an angle that we know the values for that are opposite of one another, so C. And we want to make sure that we use C in our equation. And the other piece of information that we currently know is B, angle B. And so we want to make sure that we use B over sine B is equal to C over sine C. So B over sine B is equal to C over sine C. And we'll plug in the information that we know. We know we know angle B is 108 degrees. We know the length of side C is 59 feet. And angle C is 25 degrees. And so we want to solve for the length of side B. We'll multiply both sides by sine 108. These cancel, and we get B is equal to 59 feet times the sine of 108 degrees divided by the sine of 25 degrees. Plug this into our calculator. We have 59 times the sine of 108, close parentheses, divided by the sine of 25 equals, and we get the length of side B is equal to 132.8 feet. So the length of side B must be 132.8 feet. Now the other pieces of information that we don't know yet are A. We don't know angle A or side A, and so we can't use the law of sines yet because we don't know A or sine A. But we can figure out angle A because all three angles have to add up to 180, and so A plus B plus C must add up to 180. That's true for any triangle. We're looking for angle A. Angle B is 108 degrees. Angle C is 25. So we'll add, and we get 133. Subtract 133 from both sides. These cancel, and we get A is equal to, so 180 minus 133 is 47 degrees. So angle A must be 47 degrees. Now that we know angle A, we can use the law of sines to find the length of side A. And since we already know side B and angle B, and we know side C and angle C, it doesn't matter if we use A over sine A is equal to B over sine B, or if we use A over sine A is equal to C over sine C. It's not going to make a difference which one we use. We'll get the same answer both ways. And so we'll have A over sine A. And in general, it's best to use the information that you were originally given. So originally I knew angle C and I knew the length of side C. So I should use A over sine A is equal to C over sine C. And again, because this was information originally given to me. If I use A over sine A is equal to B over sine B, when I calculated the length of side B, if I got this answer wrong, I'm not going to get the right answer for A because I don't have the right answer for B. So I want to make sure I use information that was originally given to me. So we'll plug in the numbers we know. Granted, we didn't know the angle A either to begin with, but there's not much we can do about that. A over sine 47 degrees is equal to 59 feet over the sine of 25 degrees. And so we want to solve for A. We'll multiply both sides by sine 47 degrees. These cancel. And we get A is equal to 59 feet times the sine of 47 degrees divided by the sine of 25 degrees. Plug this into our calculator. 59 times the sine of 47, close parentheses, divided by the sine of 25 equals, we get A is equal to 102.1 feet. So side A must be 102.1 feet. And now we know all of the information about the triangle. We know all three angles, and we know the lengths of all three sides. This is example 3. Again, we're given an acute triangle where we know the length of side B is 4,551 meters, the length of side A is 3,745 meters, and angle B is 36 degrees, 21 minutes, and 45 seconds. And so the first thing we need to do is convert this to decimal degrees. If you remember, to convert this to decimal degrees, we will keep the degree angle the same, and the minutes, we will add to that the seconds divided by 60, and this will all be the minutes, and so we'll take 21 plus 45 divided by 60, and so this is 36 degrees, 21.75 minutes. And so again, we'll keep 36 degrees the same, and we will add to that 21.75 divided by 60, and this will give us a decimal degree. So 36 plus 21.75 divided by 60, and we have 36.3625 degrees. So this angle is 36.3625 degrees. Okay, and so now we can apply the law of sines. We know angle B, and we know the length of the opposite side, so we know we want to use B over sine B. The other piece of information we have is the length of side A, so we're going to use A over sine A is equal to B over sine B. And so we know A, we're looking for sine A, and we know B, and we know angle B. And so A is what we're looking for. Angle, the length of side A we have, that's 3745 meters. We're looking for the angle A. Side B we know is 4551 meters. Angle B we know is 36.3625 degrees. And so again, to solve for sine A, we will multiply both sides by sine A. We'll multiply both sides by the reciprocal of this fraction, and we're going to get sine A is equal to 3745 meters times the sine of 36.3625 degrees divided by 4551 meters. And so we'll go ahead and work this part out, and then we'll take the inverse sine. So the sine of A will be equal to, we have 3745 times the sine of 36.3625, close parentheses, divided by 4551. And we have the sine of A is equal to 0.4879. Now we'll take the inverse sine of both sides. A will be the inverse sine of 0.4879. Type that to our calculator. Inverse sine of 0.4879 is 29.20 degrees. 29.20 degrees. Angle A must be 29.20 degrees. Now that we know angles A and angle B, we can find angle C. We know that they all three must add up to 180 degrees. So 180 minus 29.2. And maybe I should go ahead and write this as 0.2026. Since this angle is out to 4 decimal places, I should probably keep this one to 4 as well. 2026. Okay, so 180 minus 29.2026 minus 36.3625. And we get angle A is equal to 114.4349 degrees. I'm sorry, not angle A, angle B. Angle B. Angle B will be 180. No, I'm sorry. How about angle C? Angle C will be 180 minus 29.2026 minus 36.3625. So we found angle C. That's 114.4349 degrees. The only piece of information that we don't have now is angle C. And so again, side B and angle B, that was the original information given to us. We should use that in our formula. We are looking for side C, so we're going to use B over sine B is equal to C over sine C. So we're going to use B over sine B is equal to C over sine C. plug in the information that we know. Side B is 4551. Angle B is 36.3625. This will be equal to side C, which is what we're looking for, divided by the sine of angle C, which is 114.4349 degrees. So we're looking for C. We'll multiply both sides by the sine of 114.4349, and we will get that C is equal to 114.4349. C is equal to the sine of that angle. C will be equal to the sine of 114.4349 degrees times 4551 divided by the sine of 36.3625 degrees. So again, all I did is multiply both sides by the sine of 114.4349, and we got C equals sine of 114 times 4551 divided by 36.3625. So we'll plug this into our calculator. We have the sine of 114.4349, close parentheses, times 4551 divided by the sine of 36.3625 equals. And C will be equal to 6988 meters. So the final information is that side C is 6,988 meters. So now we know all of the information of the triangle, we know all three angles, and we know the length of all three sides.